Hello guys, I'm Siddhant of Team 628. We are working on behalf of Texas Instruments Innovation Challenge 2015. Electricity was discovered by mankind to make our lives simpler. We have been using it for over a century now. Now, I have grown bored of the switching boards that we have been using now. We always have to get up and go to the switches to turn it off. What if I say that you won't have to get up? What if I say that the control of your appliances is there in your own hands, through your phones that is, or even your smartwatches, via apps? What if I say that load switching was much more simpler? We are working on a project of wirelessly controlling loads. By loads, I mean the everyday appliances that we use, like TVs, bulbs, our mobile phones, laptops, geysers, iron, etc. And the list goes on. By the help of the components provided by Texas Instruments, we have come up with a basic model. These components are MSP430 microcontroller, CC1101 transceiver, and TPS 616762 voltage regulator, and additionally we are using a solid state relay JGX 1505 FB.
This is a system level block diagram of our project. The system level block diagram shows a master board with its different distribution boards. The master board is a device that remains with the user. It is portable and it communicates with the distribution boards through a RF communication. The frequency we are using for our project is 433 MHz. The master board issues commands to any of these distribution boards which are in the different rooms. The distribution boards can then trigger on or off any of the devices or the loads in that particular room. This is accomplished by the load switch. We are using a load switch called solid state relay. Now let me explain what is a solid state relay. A solid state relay is a power electronics device that can trigger a 220 volt AC device using just a 3.3 volt DC line. So once the distribution board has a command from the master board, it can trigger the solid state relay and the solid state relay can switch on the load or appliance. Using this concept, we can easily control any of the devices in the entire house with just a click of the button in the master board.
This is the circuit diagram of the master board. The battery is providing 4.5 volts to the voltage regulator, which maintains an output of 3.3 volts, providing it to the MSP microcontroller, which is connected to the CC1101 transceiver equipped with a 50 ohm antenna.
This is the exploded block diagram of the distribution board. Every house has one master board with a customer, and every room has a distribution board. Now, within the distribution board, there is a microcontroller. We are using MSP430F5438A as the microcontroller. This microcontroller is powered up from the battery. The battery 4.5 volt line is converted to 3.3 volt line through a voltage regulator. We are using TPS 62172 from Texas Instruments as the voltage regulator. This is the 50 ohm antenna. It is connected to the CC1101 receiver. The microcontroller is always waiting for a signal from the CC1101. As soon as the master board sends a signal, this CC1101 receives it and sends it to the RX buffer. Once the MSP430 microcontroller has the signal, it triggers one of these load switches depending on which switch is to be switched on. The load switch is a solid state relay. The solid state relay can switch on any of these devices or switch off any of these devices as and when required. This is the final product, what it will look like. This is the master board and this is the final product. The master board comes with an LCD screen. The user can now see the status of all the switch on devices and the switch off devices of his house on the screen. The master board comes with a matrix keyboard. All the devices in the house has a coded number. The number are related to the matrix keyboard here. Suppose I want to switch off this light suppose the light number is 1 and I have to press this button. It's off now. Suppose I want to switch on again. It's done wirelessly. This is the distribution board. This is how the final product looks like. Within the distribution board there is an MSP430 microcontroller. It is interfaced with the CC1101 SPI through SPI interface. We are working at the frequency of 433 MHz. The signal from the master board is received by the CC1101 and is transmitted to the MSP430 through this interface. Once the MSP has the data, it knows which load to switch on through this solid state relay. Now coming to the solid state relay, it has two inputs. It's a 3.3 DC input. The output is switches on the 220 volt AC line. The one line of the AC comes to the pin number 4 and the other line goes to the load. So once the input is given to a GPIO to pin number 1, the solid state relay switches on the load. If it needs to be switched off, this GPIO is pulled down internally by the microcontroller and this load is switched off. Thus, we can show that only by RF communication and digitally controlling this solid state relay, we can actually switch on or off this load. As you can see, this system absolutely replaces the manual switch boards. This thing can replace all the switch boards, and it is a very efficient way of creating a new kind of a switching of loads.
The project we are working on has a huge marketing potential. Imagine a physically handicapped person won't have to think twice to go to the switchboard to even switch off any appliances he wants, or an elderly person who can easily switch off any appliances he wants in his own house without any extra assistance. Hence, we can say that our project is viable.
I think this is a great project because it can be very easily upgraded to allow users to control their electrical appliances via the internet, like from a smartphone app.
If you all saw the video and you liked it and you think it's a cool concept,
go ahead, like it and share it. Thanks for watching.